Hi guys, I hope you are fine. Me too, I'm fine. So today guys, we are going to look at differential equations. That is solving differential equations using Laplace transform. So we are going to attempt to solve this equation. Already guys, I have done it, but we look at what I have done. This is the equation and these are the conditions. So the first thing guys is that we recall that the Laplace transform for the second derivative of t is given by that. That is s squared Laplace transform of ft minus s function of that is initial, that when we have t equals to 0, and then the function of first derivative with t equals to 0. And then we have the Laplace transform of first derivative, we get that. So now guys, we come and replace this equation with the Laplace transform. And we do that guys by now coming, when we come to this, we are going to write that equation right here. This is the equation we are writing. Similar to this is just what we are writing here. We write s squared Laplace transform of y, that is function of t, which is y for us, minus f function of t when t is equals to 0. This one, when t is equal to 0, y is equals to 2. So finally this one will end up being 2s. And the function of t, that is the second, when it has been differentiated, not second but first derivative, which is equal to 1. So this one is going to be equal to 1. Minus 4, in the equation we have 4, then first derivative, we write it in terms of Laplace transform, which is now given by this. Because this one we can be able to substitute that one with 2, because this f0 is the same as the y equals to 2, because this 0 represents the initial condition, that is t equal to 0, or that is now our t equals to 0 once again, which gives us now 2. Plus, now we come here, we find the Laplace transform of y, which is here. This is equals to 0. And so from there guys, we come and now replace what I have already said. We replace this f0 with 2. We replace this one with 1. Minus 4. This one we replace with 2. And this one now we replace. This is actually supposed to be 2. This is, we have 4s. This is for the first one. 4s we have y, and then from there we have, this is the first derivative. The first derivative we have that and that. This one is supposed to be replaced with 2. And that's what I have done here guys. Actually what we have done is that I have removed this bracket. So I have multiplied here 4 multiplied by 2. Now plus the last one is 3 Laplace transform of y. This one now gives us 0. Now we can factor out the Laplace transform of y. We are left with that. And then minus 2s minus 1 plus 8. All this we can bring it to this other side. We can take it to this other side. When we take it, of course this one will have to be minus 1 plus 8 is plus 7. So when we bring it this other side, we shall have 2s minus 7. And this other side we are left with this. So we can make the Laplace transform of y the subject of the formula. When we make it the subject of the formula, we shall be left with y on this side, Laplace transform of y on this side, and this other function with s on this side. For us to get y, we shall now look for the inverse Laplace. On this side, we look for the inverse Laplace. So when we do this, guys, we are left with only y for this side. For this other side, we look for the inverse Laplace for that. And that one, guys, we come and divide it into what we call the partial fractions. And guys, as we have learned a lot to do with the partial fractions, can give you an assignment for you to get A. The A is supposed to be 5/2, and the B is supposed to be -1/2. This is an assignment, guys. That's why I did not do it, or I did it, but I did not put the work in here, so that, guys, I can give you some assignment. Go find out what is A and see whether it is the same as what I have put down here. Find out. For example, this one I had left a plus here. This one was supposed to be a plus. Actually, it's now supposed to be a negative later, but when we were looking for it, it was supposed to be a plus here. So that now after that we get -2, and that's where this negative is now coming from. After now you have gotten your values for A and B, you come now and do the Laplace transform for that. And as you can see, because of this s-1, this tells you that there is a kind of shift theorem here. And that's why we have the e raised to t. And this other one, you can see, we have s-3. Sorry, guys, we don't have the shift theorem, but this is what now we get when we do the inverse Laplace transform of 1/s-1. We get e raised to t. And 1/s-3, we get now e raised to 3t, and the half we can factor it out. So finally, this is what we get, guys, as our equation. I hope, guys, have been well understood. If not, you can still try to understand by looking at all what I have done here. So we are able to solve our differential equation by use of Laplace transform. Actually, it is easier to do this if you compare with the other methods of solving differential equations. And so, guys, thank you for being patient. Thank you for your understanding. Thank you even for following me or being together with me as I teach you engineering mathematics. Guys, subscribe to my channel and God will bless you. Have a good day, have a good night, have a good evening, depending on where you are. Bye bye.